Alright, this is a video on the beginning of section 1.4, complex numbers, quadratic equation, and complex number systems. So complex numbers are sometimes called imaginary numbers, but there's really a difference. A complex number is in the form of a plus bi. Right? So a is called the real part of the number. And bi is called the imaginary part, right? So if a part is 0 and there isn't an a part, then we have an imaginary number, right? So if it's just bi, then that's an imaginary number. But if it's a real number mixed with an imaginary number, we call that a complex number. So really all numbers are complex numbers. And I think that's the top of the number system. So if b is 0, then you don't have this and you just have a real number. If a is 0, then you don't have this and you just have an imaginary number. And if you have both, then you have a complex number. So you can think of it like that all numbers are complex numbers, but most of the numbers we deal with just have a b value of 0. Alright, so what is an imaginary number? It has to do with this idea of x squared plus 1 equals 0, right? How do I solve that type of problem? In other words, I want a number such that when you square it and then add 1 to it, you get 0. Well, for that to be true, the value of x squared is going to have to be negative 1, right? So x squared would have to equal negative 1. And that seems impossible, but there are applications to this in real life, and I know in physics where they come across this, and where you need to be able to work with that. So we have the imaginary numbers. So if I take the square root of that, plus or minus the square root of negative 1, we just call this I, right? So this is plus or minus I. So I is equal to the square root of negative 1. Therefore, I squared is just negative 1. Right? And these numbers are on your calculator, actually. So if you look right down here at your decimal point on your calculator, right here, if you look right above that, you'll see I. So if I go, let's see, second decimal point, and hit enter, it gives me I. If I do that and then square it, it gives me negative 1. What would happen if I cubed it? So if I do second I raised to the third power, it gives me negative I. If I do it to the fourth power, I get positive 1. Well, what about the fifth power? So just hit second enter, change that to a 5. It's I again. Sixth power, negative 1. Seventh power, it starts getting weird, right? So this part right here, negative 3e to the negative 13, is some sort of error that the calculator, the way the program is written. That's practically 0. So that's pretty much 0 minus I. Right? 0 minus I is negative I. And then if you do it with the 8th power, you get 1 minus this number right here, which is practically 0. So 1 minus 0i, which is 1. Alright, if you're not able to get your I button to work like that, I think you can, let's see, that's in mode. Let's look here. You can put it in a plus bi mode, I think, right? Now let's see if I hit second enter, does it still gives me that error, but there may be situations where if I take the square root of, let's say, negative 16, this gives me 4i, right? What happens if I go back? So let me go back to my mode, go back to real. Alright, so now it's in real mode. When I try to take the square root of negative 16, it gives me this non-real answer. So if you want your calculator to be able to take the square root of negative numbers and involve the number I, then you got to go in your mode, quit, mode, A plus BI mode. So switch it from real to A plus BI. This right here is another mode. I think it's polar coordinates or something. I can't remember. Alright. So I'm going to keep mine in A plus BI mode for now, for this lesson. So what did we see? We saw that I to the first power is just I, right? So I to the first power is I. I to the second power is negative 1. I to the third power is negative I. I to the fourth power is positive 1. And then if you go up past that, I to the fifth power, it just starts repeating itself. I to the fifth power is I again. I to the sixth power is negative 1. I to the seventh power is negative I. And I to the eighth power is positive 1 again. So if I ask you a question such as, what is I to the 100th power? Well, it's going to be either I, negative 1, negative I, or 1, right? And you can figure out which one it is by just asking, does 4 go into that exponent evenly? And it does, right? You can divide 4 into 100 and you get 25. Therefore, it's just, you can think of it as I to the fourth power to the 25th power. That makes sense, right? Because 4 times 25 is 100. And we just saw that I to the fourth was 1. So that's 1 to the 25th power, which is 1. Well, what if 4 doesn't go into it evenly? If 4 does not go into the exponent evenly, then it's either going to be I, negative 1, or negative I. Right? So if I do, what is I to the 26th power? Well, 4 will go into 20. How many times will 4 go into 26? I guess 6 times. 6 times 4 is 24. Remainder of 2. That's the exponent, right? It has a remainder of 2. So we could do this as, just look over here and it's going to be negative 1, right? If you want to simplify it the same way as above, I guess we could do I to the second power raised to the 13th power, I guess, which is going to be what? Negative 1 to the 13th power, which is negative 1, because that's an odd exponent. But it's easier just to remember that this pattern always holds, and when you raise I to any large exponent, it's going to be either I, negative 1, negative I, or 1. And all you have to do is look at the remainder. The remainder was 2, so it's the same as I squared, which is negative 1. If the remainder is 3, then it's the same as I cubed, so it'll be negative I. Alright, so I'm going to flip to the back of the section on page 127, and we're going to just work some problems here. So the first one I'm going to work is problem 13, and it's 2 minus 5i minus 8 plus 6i. Alright, so you can, now this is not a variable, but you can think of it as a variable when you're trying to simplify these expressions, right? So you can combine like terms in a sense, even though it's not a variable. It is a constant. I is the square root of negative 1. So I can distribute that negative, and I get 2 minus 5i minus 8 minus 6i. Right, now I just combine the real parts. So 2 minus 8 is what? Negative 6. And negative 5i minus 6i is minus 11i. And that's going to be your simplified solution. You can also do it on your calculator. So I'll just put it in just exactly the way it looks. 2 minus 5i minus 8 plus 6i, and you see I get negative 6 minus 11i. Alright, what about multiplying complex numbers? So number 19 is 3 minus 4i times 2 plus I. So you would multiply these just like you'd multiply out any two binomial polynomials that you have, right? So you multiply the 3 to this and this, right? So the 3 has to get multiplied to each term over here. So 3 times 2 is 6. 3 times I is just 3i. Then you have to multiply the minus 4i to both terms as well. So minus 4i times 2 is minus 8i. And minus 4i times I is minus 4i squared. Alright, so this is going to be, let's see, well, I squared, remember, we just set up here I squared is negative 1, isn't it? So this is really 4 times negative 1. Well, you can think of it as negative 4 times negative 1. So that whole thing is just going to become plus 4. So let me rewrite it as 6 plus 3i minus 8i plus 4. Alright, if you're confused about that, you can just put it in your calculator. So if I do negative 4 times I squared, you see I get just 4. Now I can combine the real parts, so 6 plus 4 is 10. And I can combine the imaginary parts, 3i minus 8i is minus 5i. Right, so that's an example of how you can multiply complex numbers. 27. 6 minus I over 1 plus I. Alright, so I guess technically this is not in simplest rational form, because remember I really is a square root, isn't it? And it's bad form in some sense to have a square root in the denominator. So we can get rid of that by multiplying by the conjugate of whatever the denominator is. And to get the conjugate of a complex number, all you do is change the sign of the imaginary part. That's it. So the conjugate of 1 plus I is 1 minus I. So I'm going to multiply this 1 minus I and 1 minus I. And what will happen is when I multiply this to this, I will get a whole number. Alright, so let's go ahead and multiply that out. So 6 times 1 is 6. 6 times minus I is minus 6i. Minus I times 1 is minus I. And minus I times negative I times negative I is plus I squared. On the bottom, we get 1 times 1 is 1. 1 times minus I is minus I times 1 is I, so that's plus I. And then I times negative I is negative I squared. Alright. So you cannot cancel, remember, you cannot cancel these terms. These are not factors, these are add-ins, right? That these things are being added and subtracted from each other. So I can't just cross those out. It's a common mistake. So I want to simplify everything up here. So it looks like I have, this is going to just be negative 1, right? Remember, I squared is negative 1. So it's 6 and negative 1, which is 5, minus, these two are the imaginary parts, so minus 6i minus I, that's minus 7i, over, remember I squared is negative 1, so it's minus I squared, so that's a plus 1, isn't it? So this whole thing is the opposite of I squared, and remember I squared is negative 1. So what's the opposite of negative 1? It's 1. So that's a 1, and that's a 1, so that's a 2. Negative I, positive I, they cancel. So we get 5 minus 7i over 2. Alright, let's try one more like that. Let's do 24, 13 over 5 minus 12i. Alright, so what do I multiply top and bottom by? Right? So the idea here is to get the I out of the denominator. Right? So you got to multiply it out by multiplying by the conjugate of this complex number, which is 5 plus 12i. So 5 plus 12i. Remember, the real part does not change, only the imaginary part changes. It went from minus to plus. Over 5 plus 12i. So I multiply this by 13. 13 times 5, I think that's 65. Yeah. And then 13 times 12 is 156. So plus 156i over 5 times 5 is 25. 5 times 12i is 60i. Negative 12 times 5 is negative 60i. And you see that those two are going to cancel out, right? And that'll always happen. So really you could just multiply the first part and the last part, because the middle part, this right here, and when I multiply these two and then multiply these two, those always cancel. Alright, and then minus 12i times 12i is negative 144 I squared. Alright, so this is going to be 65 plus 156i over, these cancel. That I squared is a negative 1, so it changes this negative 144 to a positive 144. So it's 144 plus 25. So 144 plus 25 is 169. And that is it. Now that can be simplified. In the book, the answer is 2 fractions, right? I guess all these numbers might be divisible by, let's see. Not that you'd ever guess that 156 would be divisible by 13, but it is. So I can divide all these by 13, right? So since I can, then the book does. If you were to leave your answer this way, that would be fine with me, but if you're doing your homework online in my math lab, then that might not be a, an option. They might just have the simplified answer. So 65 divided by 13 is 5. 156 divided by 13 is 12, so that's 12i. And 169 divided by 13 is 13. So now it's in simplest form. All right, 33. I to the 23rd power. Well, it's going to be one of these, right? It's going to be one of, let's see, I started writing. I did write them here, didn't I? It's going to be one of those four. Sorry, you can't see that, can you? One of these four right here. So, let's see, how many times does 4 go into 23? Well, it goes in 5 times, right? With 3 left over. So that's the same as I to the 3. Because when I divide that by 4, 4 goes in that 20 times, right? Sorry. 4 times 5 is 20. So the remainder is 3. And I to the third is negative I. And that's it. Alright, so can I do that on my calculator? Yes. You're going to get some noise, however, when you do it, I think. So when you do I raised to the 23rd power, you see you do get negative I right there. This first part, 13e to the negative 13, that's 0. Right? So what's 0 minus I? It's negative I. So it does give you the answer, although you wouldn't know it when you first see it. Alright, so that's 33. 41 is I to the 6th minus 5. So what is I to the 6th? Well, I actually wrote that one up here, right? That was negative 1. I to the 6th is negative 1. So negative 1 minus 5 is negative 6. So I to the 6 minus 5 is negative 6. In the next section, it says, perform the indicated operations and express your answers in the form of a plus bi. So I'm looking at problem 49. So that's the square root of negative 25. Well, the square root of negative 25 is, well, what's the square root of 25? It's 5. What's the square root of the negative? It's I. And if you're just given the square root, you're not solving an equation, we'll just think about the primary root, which is the positive one. So 5i is a sufficient answer. Alright, 53 is solving an equation that has a complex root, so x squared plus 4 equals 0. We can solve that directly by subtracting 4 away, so x squared equals negative 4. Now I'm taking the square root, so x equals, since I'm solving an equation, there are two answers to this. There is a positive and a negative square root of 4, square root of negative 4, which is plus or minus, well, the square root of 4 is 2, and the square root of the negative is I. So it's positive and negative 2i. So that was 53 and 59. Another equation, x squared minus 6x plus 10 equals 0. So this right here will not, I don't think it'll factor. Can you think of two numbers that multiply to 10 and add up to negative 6? Well, 2 and 5 are the only 10 and 1. You can't get negative 6 out of that. And obviously, the answers to this are going to be complex. So if I try to graph this function, it won't even cross the y-axis. So I can't even find the answer that way. Assume 6. So you see, it doesn't even cross the x-axis because it doesn't have any real solutions. The only solutions are imaginary. So when a parabola doesn't touch the x-axis, then if you set that function equal to 0, you're not going to get any real solutions. Alright, so how can I solve it? Well, you can use completing the square or the quadratic formula. And the quadratic formula would be, well, x equals negative b, which would be 6, plus or minus the square root of b squared, which would be negative 6 squared, minus 4 times a is 1, times c, which is 10, all divided by 2a, which is 2 times 1. Alright, so that's going to be 6 plus or minus the square root of negative 6 squared is positive 36. This is going to be minus 40 over 2. Well, this is going to be, what, 6 plus or minus the square root of negative 4. Right? And the square root of negative 4 is 2i. So this is going to be 6 plus or minus 2i over 2. And the 2 will cancel with both of these, so that's going to be 3 plus or minus I. So remember, that's two answers. 3 plus I is an answer. 3 minus I is an answer. And I think I'll stop there. I'm at the end of the page. It's been a long video. Thank you for watching.